With more devices coming online every day, network connectivity has been more important. But that raises a big question. How do organizations stay connected as they scale across these devices without opening the door to security risks? When it comes to solving the connectivity dilemma, visibility is the name of the game. Organizations need to detect, identify, and understand every device on a network in real time. Here to explore the topic of connectivity is Stephen Bird, a senior technical manager at Aruba. Having seen a massive shift in connectivity expectations brought on by remote work, Stephen is working with organizations as they adapt and grow to handle the onslaught of devices. In this episode, we explore the role of standardization, how data center visibility is a critical piece of the puzzle, and what it means for IT leaders getting ready for changes brought forth by 5G and AI. Tell us a little bit about your background. What led you to focus on connectivity and security?
So I was doing connectivity and security for investment banking, decades ago now, over in Tokyo. And then I kind of moved around a few other countries, and I got into more startup space and went around security startups doing various products there. And then HV Aruba kind of hoved into view. We started talking, and I realized I'd missed out on the whole Wi-Fi revolution. So when I started on the connectivity side, it was purely switching, and everything was on the desk in a hot desk, kind of like you just kind of plonk it down and you're connected, but it needed a wire. And I hadn't actually touched Wi-Fi. I got kind of interested again about that side of the connectivity space. And so took the job, and lo and behold, it's become uber relevant and very exciting. So yeah.
Yeah, I think it's one of those things that we all take for granted now, right? But 15 years ago, wired was critical.
Docking stations, remember those? You always have to have a docking station. You push it in. I actually missed them, but you push it in, push the laptop in, and then all of a sudden you're off to the races. But yeah, there was no walking around and anyone could get you anywhere. You had to try and find somebody.
Can you share a defining moment in your career when you saw the challenges of network connectivity firsthand?
So, real simple one, COVID. Nobody in the office. Therefore, all those docking stations are just not being used. You can't get to one. You can't get to the office. You can't connect on the wireless network within the office to get to your services. A huge pivotal moment for hybrid work happened with COVID. And so everybody was scrabbling around for solutions to get their employees and access to the services. And in some respects, some places were really unable to do that with the level of security that was needed either. So that was the other challenge was, sure, you can get the connectivity, but how do you know that connectivity is as secure as it once was? Because we're kind of throwing things at the wall here, trying to get it working. And we had a great approach to that. We sold a heck of a lot of products that we had already pre-made for that, which is the little hospitality access points that sit on the desk, and then they kind of phone home with IPsec tunnels, and you have the same experience using one of these on your kitchen countertop that you would if you were in the office. You've seen the same SSIDs, you've seen the same Wi-Fi networks coming up on the screen, you can connect to the same services. So that was huge. And that flexibility in the workplace was a huge eye-opener for me. And it morphed into a lot more than just connectivity. It was being even more creative about how to get those services and secure those services to all of the people that needed it.
That's one of the things that so many take for granted, right? Is the security associated. Everybody wants to be connected, but the critical piece, especially when it comes to the workplace, is that you are connected, but securely.
Yeah. And we used what we had, of course. So everybody, every company, every place used what they had. And many of them dipped into VPNs. VPNs became prolific. Everybody had a VPN client and they started using that. VPNs weren't made for that, of course. VPNs were made for system administrators to work on Saturdays and Sundays on the infrastructure. That's how it started. And so you had this little kind of key, an RSA secure ID key, which had a number which constantly changed, and you carried it around. And then if you needed to go into the VPN, that's how you authenticated through, with your password and this little number. So very early two-factor authentication, which again is something we take for granted. But VPNs were not made for that, and it didn't have all of the controls and security controls that were needed for normal traffic, for employees to use. It's a little bit of a dark horse once you're connected and no one's really sure what you're doing. So, but we used what we had.
So starting at a high level, right? How would you define effective connectivity for an enterprise? And what are the key things that enable effective and secure connectivity?
So there needs to be visibility first into what's connecting, not who's connecting. I mean, who's connecting we do with the authentication itself, but also what's connecting. So if you go to the office and you plug in your corporate laptop, that's fine and dandy. But when we want to give access to all of the resources you need, but when you plug in your Xbox to the same place and you put your Xbox on the network with the same credentials, we need to give you different access, because we don't want the Xbox accessing all of the other things, because the Xbox is inherently not secure. Now, the password's the same, but we need the visibility of the device first to actually place it in the right area and give the right network access. So that's the first part of securing connectivity down, is understanding what's coming on and then assigning access accordingly.
I mean, what are some of the biggest, from your perspective, right? I mean, you've been in this industry for a while. What are some of the biggest challenges that businesses face in managing that connectivity?
That is a really great question. So we've been challenged there. The industry has been challenged there. And devices that connect to the network have changed. It used to be that everything was very standardized. They were made by a big brand. It was a Mac lab book or an iPhone. But now we're seeing all these IoT devices come onto the network, and anybody and their brother or their dog could buy a Wi-Fi adapter and stick it onto anything they want to. And now it has network connectivity. What is it? Dunno. It's just a Wi-Fi adapter. But we don't actually know what the device is behind that Wi-Fi adapter. So we had to get a lot more creative about the visibility aspect, because just looking at those static attributes, which could be manipulated, wasn't enough anymore. So instead of that, we built into the code of the Wi-Fi access points, the switches, our gateways, an engine so that we're actually profiling every device that comes on. And we're looking at more than just what they're using for DHCP options or all of the flags associated with that, the ARP requests. We're now looking at, okay, so what application are they using? What's the application ID? How often are they reaching out? What destination are they going to? And all of these things, what port number are they using? All of these kind of things, these are tells that allow us to be a lot more exact about what's connecting to our network. And up in the cloud, because we have the cloud compute now and everything kind of moved to the cloud for collating all this information, machine learning could be used, automation could be used. And in that way, what we're able to do is not only see what comes onto the network with a high degree of accuracy, but we can also tag it, make those part of the criteria that actually compartmentalize it, and then use that in our security policy for anything else that comes onto the network. So let's say you have, a CCTV camera, and you have a certain brand and a certain type of CCTV camera, and it connects back and it talks to your CCTV server. Well, you don't want somebody else coming in with the same brand of server and they try and replicate the model and they stick it in. You don't want them connecting back to that server. You want to make sure that it's only the ones that you want out there. So because of that different criteria that we can measure on, we can put that as part of that categorization, so that every time you send out a new CCTV camera from within that categorization, it will join the network, it will get that same network access. Whereas all of the other ones, which are the copies, will not. Now that keeps not only your CCTV footage safe, but it also allows you to scale and automate all of the rollouts as you go across different sites.
So there's a level of device profiling. So not only this is Jonathan's device, but it's that class of device and the traffic. You're leveraging the information that's coming in about where the traffic is going and what the volume is. And so you can sort of back solve to what it is that it is, and then make tags, assessments, security decisions based on it.
Right. I mean, they all become identifiers of that product and that brand and that model and that series number or that serial number. All of this kind of stuff gets passed through. And because we put that code in where they're coming onto the network, we're able to address it immediately and give it the right access control. So that's the visibility part. And that's the first step of allowing it on there. But to your earlier question, we need to automate these things as much as we can. And we use what's available to us up in the cloud with all of that compute, with all of that performance that we can utilize because we have a very large environment to benefit the customers. So they don't have to make it on-prem. They don't have to do it themselves.
I mean, as you mentioned, right, more and more organizations are having a hybrid. They're moving to the cloud, and they've got on-prem, they've got hybrid, they've got a diverse strategy. So as enterprise is shifting in that direction, how should they rethink their approach to network standardization and governance? And how does that affect the performance and the experience that employees have?
So that's a great point too. I mean, the experience of the user ultimately dictates whether they feel they've had a good experience and a good performance network, right? So if for some reason something is different, that's a hurdle. So what we try to do is centralize all of that and push it down to all of the different components that make up network access. So switches, access points, maybe cloud portals, going across a WAN link from site to site. We've consolidated that, and we try to give a very similar experience to get those devices to actually authenticate and get onto the network. So it's a very broad portfolio. So we have the stuff which is on site, the access points and switches for office buildings and branches. But then we also have things for people on the road that can only get to a cloud portal. And that's a similar system, and that gets them onto the network through there as well. But we share rule sets and we share visibility amongst all of these different solutions and try and manage it from one portal, which is called, in our case, Central. But I think that's where most of the industry is going.
So we're seeing that that people's organizations' approaches to managing network has moved from being localized to being centralized.
Yeah, so the control is centralized, the management is centralized just because of scale, to be completely honest. So we need to manage everything at scale, and things change fast because the amount of devices coming onto our networks are now so diverse, and there are so many of them. I think the statistic is 55 billion is coming online, 55 billion different devices in the next couple of years was the last statistic I saw, which is a huge amount. And you cannot manually allow or do some kind of administration to get each one of those on. You just can't do it. So having it centralized, having it scalable, having it automated as much as possible using AI on the back end. We use a lot of AI and machine learning up in the cloud. So we take care of that for our customers because it's a lot of compute power. It's very expensive. But the more of this that we build in to all of the networks, the better. And that's what we're striving to do.
So tell me more. How is AI playing a role in managing network security and network devices? And along with that, I am curious, how does that marry with the commonplace of people bring their own devices, right?
So we use AI in many different ways, actually, within the solutions. Sometimes it's more front-ended. So it's around kind of like the machine learning, putting all that together, identifying the machines that are coming onto the network, which we talked about. Sometimes it's like that. Other times we create automatic thresholds of what is normal versus what is not normal. And we used to call this kind of behavioral analytics, but that's all built into the platform as well. But that's all AI based because you're taking in real-time data, you're publishing it, and then you're making this threshold and you're looking for anomalies or you're looking for something that's happening out of the ordinary. Now, on the back of that, what we're also building in is, well, there's two parts to it. One is recommendations of what to do with the controls or different configuration changes that need to happen on the back of these anomalies. That's all part of AI. And what we're also doing is we have something called AI Assist within the central platform, and that reaches out to all of the different aspects, all of the different products that may be making up this problem, and grabbing the logs and pulling them in to do more data analysis. So rather than it just running off of, oh, I see this, I see that, I see this, it says, oh, I see this, let me check. And it goes out and pulls some statistics. And we're actually, again, same talk track with going down that path of trying to automate on the back end of this so that the administration don't have to do anything. It's almost a self-healing network.
Well, that's incredible. So it's leveraging the technology to handle all the different fluctuations. Can you help me understand what you mean by a self-healing network? How could a network get sick or break? I've heard this before, but I just don't fully understand.
There's no ambulances, there's no doctors. But what does happen is the AI tools are kind of like the ambulance and the doctor, where they step in when something is going wrong, or they step in when the environment changes and something interferes with user experience or connectivity or service in general. And the self-healing network will actually reconfigure what it's doing. So in the air, there's lots and lots of airwaves, and they're all on different channels. Okay, so there's lots of, it's all kind of chunked down in between there. And so within the portfolio that we have for access points, for example, if one of those channels becomes unusable, or there's some interference, or there's something else, or there's something not working particularly well, or it's not doing what it's meant to be doing to give the right experience, it will actually change the channel for you and move it up one to a different channel that is clear. So things like that is like self-healing. So if it's not working as expected, if it's feeling bad, we heal it, but it heals itself. So that's what self-healing is. And that's just one example. There's lots of different.
So there's too much traffic, it's dropping packets, and it'll say, okay, wait a second, there's too much going on, there's too many conversations, and it'll just move it to somewhere else, sort of.
Well, yeah, it could be client-based. So it could be, oh no, we got too many people coming on via this method. We need to move some of them off. So it could be that kind of self-healing, where it's moving and load balancing.
So load balancing to some extent, yes. Yeah,
so it could load balance it. Or it could be that, hey, this media, this bandwidth channel isn't working. We need to move to a different one because there's all this interference happening. So all of that is taken care of automatically within the systems. And that's based on real-time data, of course. It's not just
right.
Yeah. But that takes
obviously streaming.
Yeah. And sometimes it's not real time. Sometimes it's on a schedule, but sometimes it's real time.
We've talked about the sheer number of devices that can exist on a single network, from personal, professional, and everything in between. We're now connecting to enterprise networks at a massive volume, and it's only growing. And while enabling that access is critical, it's far from the end of the story. For data centers in particular, the real challenge lies in what comes after. Making sense of all that traffic, identifying patterns, and staying one step ahead of potential threats. That's where strategy comes into play. It's not just about knowing what's on your network, but having a standardized, scalable way to respond when you notice there are anomalies. Whether that's unusual access behavior, unexpected device types, or activity that falls outside of policy. This is where Stephen lends his experience as the emerging technology is challenging expectations. He breaks down how standardization and intelligent profiling are helping organizations shift from being reactive to proactive, identifying potential issues before they become real problems. Let's get back into it. In the modern networking stack, what's the best practices to manage that?
In order for them to actually get connectivity, they need an IP address. Now, we have a concept of zero trust. And zero trust networks or zero trust network access to us means that we don't give any device access or an IP address until we know that visibility part and until they've authenticated through, so we know what access to give them. So there's two different things that we need to know, and then they get an IP address. That's kind of our zero trust network access fundamentals. So masking any IP address, they can't really mask it, we do it at layer 2. So we do all of that at layer 2. And then we provision network access. Once we know what they've got to get, then we can give them their IP address and access to the rest of the network and whatever we're allowing them to get to. So it's not really a problem, but that's all centralized as well. That access control. And as I say, the visibility takes a part in that, so that somebody doesn't use the same credentials for two different devices, and they get different access based on what they're using as well. And that's got to be continuous too. So we continuously watch that, so that if something does change and they start doing some funky things that they're not meant to be doing or trying to, then we can lock it down and change the access on the back of it. That's not just ours. We rely on input from other devices, third-party devices, non-Aruba devices. We take in firewall feeds or MDM feeds or Active Directory feed, any kind of feed we can take in. We can base it on time of day. We can base it on geography. We can base it on a lot of different things. So it's not particularly locked in. It's pretty granular. But we can make some decisions around not only whether to let them on or not, but actually make some change decisions based on what they do or where they come from.
What's the next big thing in networking? What is the next big thing that you see that is emergent in this field, right? We've gone from being wired to being wireless, and we've got the growth of AI to help manage workloads and keep things secure. What's that next thing that's going to be dynamic and change networking?
Few things that are coming on. SASE has already kind of come, and that's giving secure access from multiple sites or multiple geographies. So that's kind of already come and it's here. And we have a solution for that. And there are other vendors in the space as well, of course. But if we're looking towards futures, well, we're definitely seeing IoT just because of the proliferation of devices coming onto the network with that 55 billion or more that are coming on, everything having a Wi-Fi adapter. We're seeing that as the next onslaught that's coming through, and being able to manage that and being able to provide services to the right devices and secure it down is going to be key. And to that end, we're really beefing up what we can do on our access points, for example, and also our switches to facilitate that. And what I mean by that is we're adding additional radios like Zigbee radios, which are typically very low power radios for IoT devices. We've doubled the amount of radios in the APs. USB ports for proprietary IoT devices, we've doubled those on the access point. CPU power, we've beefed all of that up because more processing is going to be done on the edge to classify, to authenticate, to put them in the right place, and also manage some of the data that's coming out of these IoT devices so it doesn't have to stream across the network and then just get to a server and then get crunched up there. So some of this pre-processing is now happening within the access points for IoT data. So there's a bit of a shift from where the processing is starting to happen with IoT devices. That's one thing that I see happening.
The first thing you mentioned was, I think that's important because that's something that I've recently experienced, right? Converge, we've got offices all over the country. I visit another office, I open up my laptop, and all of a sudden I'm connected to the Converge network through the Wi-Fi. I didn't have to log in. I didn't have to find what's the password, post it on the wall somewhere. I already have that built-in level of security, and administrators have that. They now have that security, right? So there's that. The experience for me has improved as I move from space to space. And also, I would imagine from the cybersecurity standpoint, right? There's a much more comfortability, tighter level of control.
So the big change there is that Central is now the brains behind the brains behind what's going on the sites. It doesn't look after the data. The data flows within the devices that are on site, of course, but it controls that. And that means that you're able to replicate across sites, across offices, to your point. You can have the same controls. And that all comes back to that user experience of, hey, when I go from there to there, I want it to be a similar experience. I want to have the same services. And so that's what we're trying to provide, not only from site to site, but also from your bedroom or from the kitchen counter or from Starbucks. And if we can make that an easier experience for the user and a familiar one, then they're going to be able to use their services and be more productive.
I definitely can see the challenge of more and more devices coming online and the challenge to manage that. I think it will be interesting to see how edge compute starts to change things.
Yeah. It's definitely evolving. Yeah, it's definitely evolving, but that's a big driver. There's also 5G as well. 5G networks, they're becoming a little bit more of a driver towards what people need to do. We have private 5G solutions that we're basically building and bolting on into Central. And so that means that the 5G networks are very simplified. You have your own SIM cards for a private organization, perhaps, but a much wider coverage, less bandwidth than a Wi-Fi connection. But the things that you can do with a 5G connection are you can take away that shared media. So you're not having to use the same as perhaps your 60,000 stadium guests. You're not on the same network as them. You're on your own network, which means that if you're scanning tickets for people to come in, it's really fast because you're the only ones on there. The rest of the guests are doing goodness knows what. For people like emergency response, they have problems, of course, when there is an incident because everybody's on their phone. And so the public 5G networks get overwhelmed. So they need some kind of backup, backhaul kind of solution where they can communicate to coordinate their response. Or wider areas, ski lifts or ski areas, places in the wilderness. They can't run cables up to the top of the hills. They just can't do it. So they need more coverage. Pop-up events, festivals. Yeah. So there's lots of different places where Wi-Fi by itself needs to be complemented by this 5G network, but having it again in the same place and being able to control it simply is really the key, though, and that's what we're trying and striving for, as I say.
I mean, the other side of this, right, is the data center, right? So in thinking about the data center, why has visibility been such a major issue for IT teams when it comes to managing a data center?
Wow, what a great question. You have hit on something that has baffled the data center administrators for a long time. So data centers have always been a bit of a black hole when it comes to visibility. Because of the amount of traffic going through the data center and from servers and storage and everything that's in there, backwards and forwards, there's no real way to get visibility on everything that's in there. So we've had to be pretty creative in looking for what we can get. And some ways that some of our customers have done it, and we've all done it, is because there's no other way to do it. Sometimes they put sampling of data onto the infrastructure where they get 1 in 6,000 packets or 1 in 6,000 to get a sliver of visibility. And then they try and make decisions based off of that. Kind of hit and miss. The other way is to put a tap onto the wire. So they're actually like putting a vampire clamp onto the wire to replicate what's going to come out of there so they can see the traffic. And then they build another network to house it. It's crazy what we've had to do, but it's because there's no visibility. And some of us have had to put agents on all the boxes. So all of the workloads that we have these agents or software agents. And VMware has one, for example. VMware has an agent that does something similar where it looks at the flows and then it can actually control the flows. But that's only VMware. If it's talking to something else, you can't see the other side of the conversation. You just see the VMware side. So it's always been kind of hit and miss, and we have partial kind of views of what's going on in the data center, but no full visibility. And so what we're seeing is the next generation of data center visibility is in the silicon of the switches. So not software, because software doesn't scale that high because of the throughput, but silicon can.
Now, I would have thought that, I mean, data centers have been around since the birth of computers, in the sense that, like, I mean, the first computer was essentially a massive data center. I would have thought that visibility would have been a solved problem. I mean, I can't even imagine. What are some of the risks that come with poor visibility in a data center, especially in terms of security and performance?
There's a lot of risk, and it is both security and performance, but also you don't really know what's going on in the data center. So therefore, making changes to infrastructure in the data center is a little bit more dicey, because you don't know what the knock-on effects are going to be, because you don't have the visibility. You also don't know exactly, you may have some idea based on some of the workloads, etc. You get kind of piecemeal information. What happens if you ramp things up or scale it out? You're not quite sure what the impact is going to be on all of the pieces of the infrastructure, because you don't have a full view of what's going on, which makes rolling out a marketing campaign or rolling out a new service or adding a whole bunch of users to a new thing. That makes it very difficult, because you can't really scale to it, or you can't plan for it very well. So they've had these piecemeals for a while. One kind of workaround that everybody tried to do was sending the flows that are interesting, or the communication that's interesting, send it to a firewall to do east-west. It's called east-west traffic within the data center, which is basically servers talking to servers or storage. So they send it to the firewall. The firewall then talks on its behalf to the other server, and then that server talks back to the firewall. And in that way, they can get visibility. So they've tried that. And that leads to, it's not the best. I mean, you're sending the data somewhere completely different than it needs to go. It's also taking up a license on the firewall, because they're bandwidth based. So it takes up a lot of extra resources that don't really need to be taken up. So that was the other way that people did it. So those are the kind of ways people got visibility into the data center. Our approach has been, and interestingly, the hypervisors, and I'm talking AWS, Azure, Oracle, all those people, this is what they've been doing to cope with it, to get that visibility. They've put it into the switches at the top of the rack. They've put it into silicon so that they can actually do segmentation of the data, but they get the visibility and the enforcement at the switch. So everything you plug into the switch, which is everything in a data center rack, you plug it into the top of rack switch or a middle of the rack switch or something, but you plug it in there. That means everything is going to go through that switch. You have full visibility of every flow that's going on in the data center. And that makes a very complete picture, so that you can see what the impact of changes or additional services are. You can see where issues may be arising. Security-wise, you're able to stamp it down and actually do enforcement on the switch. So not only do you get the full view, you actually get capabilities to lock things down, so they can only talk to certain places. And in that way, it's a lot easier to control, because you have that visibility. So that's kind of the next step in data center. Again, it's kind of zero trust. So we're pushing zero trust into the data center. Not just the front of house where all of those clients are, but now it's in the back end. So we're actually able to control that. And that's gonna make it a lot more efficient.
I know zero trust has become a major focus in enterprise security. I mean, what do you think are some of the biggest misconceptions about zero trust?
We kind of moved away from just having a perimeter security. I mean, that's kind of gone away, I think. I think that misconception has gone now, that if you have a firewall, you're safe. I don't think anyone really thinks that anymore.
No, it feels like nothing is safe now, right?
There you go. Yeah, zero trust. There we go. That's it. The definition of zero trust. I don't think anything's safe. Yeah, that's it. That's it. Exactly. I mean, we went kind of defense in depth after the perimeter security. So we said, firewall, I'm safe. And then we said, I need more controls down here. And we did defense in depth. So if it got through the firewall, then it has to get through this, then it has to get through this. And we did layers. That was the next approach. Now it's zero trust, which is don't trust anything. Corroborate everything before you do anything. And that's kind of the premise of zero trust.
In networking, I would think in networking, if you can't trust anything and you're checking everything, I would feel like that would slow things down.
Yeah, I mean, a little bit, but on the whole, it's manageable. So if you centralize it and if you automate it, then it's not actually that arduous. The actual control and the checks and balances, if you push them to the edge, they scale. The central is just for the policy, for looking after everything, but the actual enforcement and the back and forth and shall I do this, that's being taken care of at the edge. And it just gets information of what to do from the centralized control. In that way, it's manageable. If you pushed everything centrally, it wouldn't work.
Right. And I mean, so you were talking about how you're pushing that observability and the security into the silicon now.
For the data center, definitely. So yeah, for the data center, it's pretty static, more static than all the people walking around with 10 devices. It's a very different kind of play. So the data center tends to be locked down more. So we can have more rigid, strict, static controls. But then we just need that visibility where we pass it through the silicon to get that visibility so that we can plan for things and get an idea of what's actually happening in the data center. On the front of the house where everybody's coming in, that's where you've got all these devices coming and going, different devices joining. And that's where we need to identify what it is first, do some authentication, put them on the network, and then monitor what they do and always have an option to change that access.
I mean, we're hearing a lot about AI and automation in IT. How do you see these technologies influencing the future of connectivity and data center security?
On the data center side, one of the key things that we need to actually make decisions is a full picture of what's going on. And that's where that data center visibility through silicon DPUs on switches comes in. Now, on the back of that, you feed that telemetry, you feed that information into an AI engine, perhaps, or another smart engine or another tool, perhaps. And then you get a full rundown of how things are being used, what the changes have been, anomaly detections, etc., etc. So AI is going to sort through that for us because it's standardized data. What we can't do AI to do very easily is to say, okay, take that data. We know they're completely different. Now make sense of it. So unfortunately, it's going to struggle. We're again at a point where we have false positives, which is something we can't have. So having a full picture of what's going on is going to enable AI to give us more actionable information on what's going on. So that's one of the outputs of having that full visibility. AI on the other side. So some of the things that we're doing with AI on the front end for the campuses, for the retail offices, etc., is we're actually doing a like for like inference of how you're doing against other sites that are similar in size, similar in layout of what they're using, similar in products. How are you doing against that? So we're not only are we baselining what you're doing and looking at whether there's any anomalies, we're saying, oh, well, this retail store looks like that retail store from another customer. It's all metadata, but we're doing some kind of comparison there to say, well, if you change this, you'll probably get better throughput. Or if you do this, you might have less performance issues. We're looking across that to get more and more. We have a huge data lake in Central. I mean, it's huge. We now have, over 2 billion endpoints, clients on Central. And that's a lot of data to pull from. So we've classified and we have profiled thousands and thousands and thousands and thousands of devices. So every time something comes on, we're able to say what it is because we're crowdsourcing all of that metadata to say, okay, this is such and such a widget, or that's a light bulb, or this is a fridge. And then based on that, it gives you a full picture of what's going on and you can say what you want to happen with it. So having that data and having that data lake is huge. We've got thousands of customers. We're ramping up fast. It's a couple of 100,000 kind of different configurations to look at. So we're able to actually mix and match. AI does a lot of the work for us there to say what's working, what's not. And then we're able to pass that on to the customers within that platform.
It just came back to me. One of the things that you mentioned, right, is that in the future, we are going to see more and more devices attaching to networks, especially IoT type devices, right? Which is going to increase that east-west traffic. When it comes to managing and securing and observing that, is it fair to say that is part of the reason why we're going to need more compute at the edge to manage that and optimize it? Or do you see any big challenges by this massive increase in east-west internetwork IoT traffic, right?
Yeah, I mean, we need more compute to allow more devices to come through each radio. So in the past, when we planned for radios, we planned for access points and Wi-Fi within a place or a location, we looked at the size of the location and we said, oh, we need to have coverage across this location. We need to see how far does the radio stretch. Now it's more, okay, how many devices are coming onto this network? How many devices does each person have? And that number is incrementally going up each time we look at it. So it used to be everyone had one device, a phone, and then all of a sudden there was a peripheral device. Now it's 3, 4, sometimes 5 different devices that they connect to when they walk into a room. And so the radios have to associate all those 4 devices, 5 devices. So that's become more of a bottleneck than a coverage area. But yeah, so we've raised the compute on the platform there. We've also got containers within the APs. We do app identification, so we know which applications they're using as they're going through things. And we control the security, the access, even quality of service for some of those applications as well, because we can identify them. And that's the same on the switches too. So when they plug in on the wired side, or if they have devices going through on the wired side, we can do the same thing there.
What advice would you give to IT leaders that are looking to modernize their networks and their data centers?
Look for anything automated or any kind of automation tools you can, so that it can, once you've set a policy, that policy can then translate to all of those app connection devices underneath it. What we're trying to do now is we're trying to actually have a policy based where we can actually configure some parts, and then the tool that you're putting it into translates what needs to happen to a switch, an access point, a gateway. It doesn't matter. It does all that configuration for you. You're just saying what you want it to do, and it'll configure everything underneath. So the more you can automate that, and then you can reuse those different parameters. As you look at tools, look for those kind of functionalities that are going to make life easier, that automate a lot of the day-to-day. And it may be changing a switch port. If you have a switch, then maybe at the moment you're manually changing all of those port settings and saying, okay, well, I need this to be this VLAN and I need that to be that VLAN. Maybe you're doing that every time someone's coming in. Look for automation there. Look for something to say, oh, this is a printer. I identify this printer's great. I'm going to change the port settings to the printer port settings because it needs access to this, but nothing else. Look for that kind of automation that can change those port settings. Same as Wi-Fi. Look for things that are going to automate and make your life easier, because you're going to see a lot more devices coming on. And the last thing you need is someone to be calling your help desk every time they need something.
What's next for Aruba? I mean, are there any exciting developments that are on the horizon that you can share with us? Give us a little inside peek.
We've got a lot of very exciting things coming up. In particular, we have an asset tracking kind of functionality that is being put into our environments, into the wireless environments, where it's actually using longitude and latitude GPS chips that are embedded within the access point and self-positioning themselves on a map. And then looking at the other APs, looking at the other access points around the place to identify where they are in the world using longitude and latitude. And then on the back of that, we're able to use beaconing from those access points to look for different devices and tell you exactly within inches where they are in the room. So yeah, so that's quite an exciting one. And also in the access points, it's kind of a quirky one, but we put a barometric pressure sensor so that we know what altitude it's at. And the reason for that is so we know which floor it's on. Yeah, it's just an interesting tidbit that I was quite surprised to see it, but yeah.
That aligns well with what you're saying, right? The more data that you've got to understand the environment, the better experience you can provide. And if that means automating things, automatically knowing where things are located, right? That increases that visibility, improves the overall experience that you're providing. And hopefully people, they don't see the network. They just enjoy the experience.
Yeah. I mean, there are some practical applications to that asset tracking. So typically in hospitals, they don't know where the crash carts are. If someone's crashing, you need a crash cart. So if you can find it quickly, you're ahead of the game. So there's a few things that work into practical kind of things, finding things that are lost, things that tend to be very mobile and people need all the time that are very expensive. Being able to track them is always a good thing. But yeah, user experience, walking around a mall, knowing where you are, getting directions as you go around places, fantastic. So yeah, lots of things coming through within Aruba that's very exciting. The data center, lots of interest there, lots of interesting technologies being put together there to enable faster speeds, to enable AI. So all of those AI machines and servers and storage, we're facilitating the network side of that by putting in more and more of these switches into our stack. So yeah, Aruba's working hard to push the boundaries, push the envelope, and help out the IT teams that are ultimately giving all these new services out.
Incredible. This has been an exciting conversation. Thank you, Stephen, so much for joining us.
Thank you, Jonathan. I really had a good conversation with you. Thank you.
In a world where devices are constantly coming online and the edge is expanding, organizations need more than just access. As Stephen emphasized, we need control, clarity, and the ability to act fast when the unexpected happens. Standardization and intelligent profiling aren't just buzzwords. They're the connective tissue between secure infrastructure and scalable growth. I hope you enjoyed this episode of Edge of IT. For more information, visit our website at convergetp.com. And don't forget to subscribe to Edge of IT on Apple Podcasts, Spotify, Amazon Music, or wherever you listen to your favorite shows.